So once we've taken the pixels from image space, from spatial space into frequency space, and we've plotted those as a scatter diagram, how do we actually break those into classes? Well, there's a number of different methods that we can use in order to cluster all of those scatter diagrams once we've made those based on different bands. So let's go through this list. There's the minimum distance, one called the Parallelpiped, which is kind of a three-dimensional sort of parallelogram. There's a maximum likelihood classifier, and there's also a procedure called an iterative procedure called ISODATA. And we'll look at all of these, and we'll kind of do it in two-dimensional space just to make it a two-dimensional frequency space, just to make it a little more easy to understand. So with the minimum distance classifier, each point would be looked at, and it would look at the minimum distance in which a central point could be located in order for all of the points around it to have minimized the distance to that point. So these darker, bigger points here would be at a minimum distance to all of these other points, and we've kind of selected 4 of those points here. That 4 of those points have been selected so that we minimize the distance between all those points in that cluster. Remember, this would represent one band on this side, another band on this side, and each of those small points would be an individual pixel. And then once that occurs, then we can just assign those to categories. So now we're assigning pixels to different colors in this case. And then if we went back into the map view, we would see the patterns associated with these 4 different classes and this classification scheme. And we would be able to see what those 4 different categories or classes mean. So that's the minimum distance, just minimizing the distance between all of the points in any particular category or class. Maybe a simpler one is the Parallelpiped. The Parallelpiped takes a range of 1 band. This is MSS, Multispectral Scanner 7, and this is Multispectral Scanner 5. And it takes a range in this direction for 5, a range in this direction for 7, until all of the points fall within those ranges. So there would be 2 different categories here, A and B, and then once we go back to the map, this is once again in the frequency space, right? Because we're looking at one band of the remote sensing image versus another band. When we go back in the frequency space, we would see a map pattern. The minimum distance one assigns a category to each point, but the Parallelpiped doesn't necessarily do that. We can see here some points are ambiguous. We don't know if this gray point here should be blue because it falls within the blue Parallelpiped, or it should be pink because it falls within the pink Parallelpiped. So some of them can be ambiguous, and some are just uncertain. They fall outside of all Parallelpipeds or all of these rectangles, so we just don't know, for example, what some of these other gray points would be. Another way that we can do it is this way of the maximum likelihood. If we're just looking at one band, we can have from dark to bright for our pixel brightness. And if we have 2 different categories, let's say we have forest and agriculture, there might be some pixels in this area of overlap here. So these would each be like a histogram, this one for forest and this one for cropland. And there might be some brightness values where it could be either one. Once again, this is kind of an ambiguous one, like these points that occur in both Parallelpipeds. We just don't know which one. If we had an image that had a brightness value at 45, we just wouldn't know if that belongs to forest or to the cropland. But what we can do is we can just take a likelihood, right? This is sort of a distribution, kind of a normal distribution, and we would know where the first standard deviation is and the second standard deviation. And then as we get to a point here, it might be much more likely, for example, if we have a point here, that it would fall within here because there's a very low chance it would be within this distribution. And if we have a point way out here, it may be more likely that it is within this distribution because it would be very unlikely to be within this distribution. So in one way we can kind of think of these as like isoprobability lines, where the most probable ones are closest to the center here, and then it gets less and less probable as it goes out to the side. Here we've moved from just looking at one band of the remote sensing imagery to looking at 2 in combination here. And so maximum likelihood might look something like this. And once again, some of these ones might be ambiguous once again, like these two ones in gray here, but there could be a greater probability that it falls within one than within the other. So it might be more probable this one is green and more probable this one is red because it's closer to the center of the red cluster. And we could make decisions on it based like that depending on what sort of probability range we were willing to tolerate. The last method is an iterative method, and it's called ISODATA. So here we have two different bands, band 4 and band 3, and we can see that the histogram follows some sort of normal distribution here and a somewhat normal distribution here, and we can combine those all in the scatter diagram to show what a normal distribution should look like for both of those at the same time. And once we've defined that distribution, then we just put in these points associated with different standard deviations of where the likelihood or where the overall distribution of these values are. And we can start there and make each one of those sort of a central cluster. So now we've kind of divided that up halfway in between. We'll put a perpendicular line and we've made this one cluster, this another cluster, this another cluster. But then what we do is we let them behave as their own clusters and we let them compete with the other clusters for points. And we do this in an iterative fashion. So we might do this over and over again until we get something that stays stable. When this stays stable, even if we repeat the process, the clusters would not change either at all or just a little bit with multiple iterations. So now we know we have something stable and we have these different clusters defined for band 3 and band 4, and then we can take all the points within this area here and assign it to this class here. So this is especially good if we kind of have a clustered distribution overall. We're able to use this ISODATA technique in an iterative fashion in order to define the different classes or categories for the image classification.